In this video, we're going to talk about complex roots. This is the second video where we're looking at these imaginary roots. So we're using everything that we learned about imaginary numbers and everything that we learned about solving quadratics, and we're bringing it all together. One thing that we want to remind ourselves of is that I is equal to the square root of -1. And this is going to come in handy when we start looking at examples that are a little bit different than what we're used to. We don't get those real solutions anymore. We start dealing with those complex roots, which we will see some more of. So remember, you guys saw an example similar to this when we first talked about complex numbers. If we had the square root of -4, normally we would say, we can't deal with this. We don't know what to do. We've got a negative under the radical. Help. What do we do? But we learned that we can break this up into -1 times 4. And of course, what we just saw above is that I is equal to -1. So we can actually pull out that -1, and it's going to become an I. And then, of course, the square root of 4 is just 2. All right, and anytime we take the square root of something, we have to remember that plus or minus, and I'm going to write this in the correct way, as 2i. So the square root of -4 is plus or minus 2i. So as we talked before with the discriminant, if we had a negative number underneath that radical, as we do here, we had 0 real solutions. So 0 real solutions, because again, you cannot take the square root of a negative number with using real numbers. But we have 2 imaginary numbers. We have plus or minus 2i. 2 imaginary numbers is what I'm going to write. So that's just a little example right there. So basically, the only thing that we are adding to solving quadratics is that anytime there's a negative number underneath that radical, is we have to pull out that negative and use an imaginary number. So like anything we've done before in math is we are always simplifying or writing in the correct form. We cannot leave a radical in the denominator, so we have to rationalize, just different things like that. So in this case, we can never have a negative under the radical. We have to be sure to pull out that I and write it as a positive. So we're going to look at a couple examples. Remember, you can use whatever method of solving that you would like that works best for the problem. We've learned so many different ways to solve quadratics, and you can use the one that you're most comfortable with or the easiest one for that specific quadratic, wherever it might be. So if that's completing the square, solving by square root, using the quadratic formula, whatever it might be, just remember that there's a lot of different methods that we've learned. Factoring for these is typically can be very rare. I'm just going to put it out there. So you might have to use one of the other, a little bit more complex methods. And of course, you can use a quadratic formula anytime you'd like. So let's just look at this first example. So v squared plus 2 equals 0. So this looks very similar to one that we've done with solving by using the square root. So I'm going to do that here because we don't have that bx term. Remember, if you want to plug this into the quadratic formula, be my guest. But I'm going to solve this by square root. So I want to isolate that v squared term. I'm going to subtract 2 from both sides and rewrite this as v squared is equal to -2. Of course, we want to get v all by itself, so we can take the square root of both sides, and we're left with v is equal to plus or minus the square root of -2. Typically, we would just square this off, and that would be our answer. But we have a negative number underneath that radical, which we said before, we cannot leave it this way. We cannot leave a negative underneath the radical, so we have to pull out the negative. If you're not comfortable just taking out that I value, you're more than welcome to break this into 2 times -1 and then go from there. But I'm going to recognize that we have a negative there, so I'm simply just going to pull that out in front and write this as plus or minus I rad 2. And this is going to be our answer right here. So we have a positive underneath the radical. We wrote it as plus or minus. Do not forget that I value. You have to leave that I there, and that's your answer. Of course, if our If the number underneath that radical could be simplified, we would need to do that. But in this case, it's a 2. That is in simplest form. So we are done with that one. So let's look at another example over here. Let's try 3x squared plus 1 equals 0. So same thing here. I'm going to go ahead and use solving by square root. So I'm going to subtract the 1 to get that 3x squared all by itself. So we have 3x squared is equal to -1. Again, I want to get that x squared isolated. I want to get all by itself, so I'm going to divide by 3. I'm going to keep working down with x squared equal to -1 over 3. All right, the next thing we need to do is take the square root of both sides, and then we have x is equal to plus or minus the square root of -1 over 3. Now, of course, this has just a lot of wrongs with it. We have a negative under the radical, and we have a fraction, so we need to do just a little bit of extra work to simplify this. But you guys are good with these. You guys are given these more advanced problems a lot, so you can power through and do it. I strongly believe. All right, so we have learned that we can go ahead and give this radical to both the numerator and our denominator, right, like so, and then simplify from there. So here I notice that we have a radical in our denominator, which is not okay. We have to rationalize. So I'm going to multiply the top and bottom by rad 3. I'm going to multiply by rad 3. On the top, I'm going to multiply the numbers underneath that radical. So -1 times 3. I have -3 underneath the radical. And on the bottom, again, we're going to multiply those two numbers. So 3 times 3 is 9. But the square root of 9 is simply 3. All right, I'm just going to bring that number down here just to keep it going. So we have plus or minus square root of -3 over 3. I just carry the plus or minus with me because it's easy to forget that. So the last thing here is we're not done just yet. We still have a negative under the radical, so we have to be sure to take that out. Again, if you need to break this out into -1 times 3, be my guest, but I'm just going to pull it out. So we have plus or minus I rad 3 over 3. All right, so there we go. Those are our solutions to this quadratic for number 2. Of course, with both of these examples, you were able to use the method of solving by taking the square root. If you're able to recognize that there's no bx term, I recommend doing it this way. And if you don't see it and you have to use a quadratic formula, that's okay too. I'm going to show an example now where the best bet is to use that quadratic formula. On your homework, you guys will see some examples where there's not an I value. You will not get imaginary numbers every single time. There will still be some problems where you guys will get real solutions, and that's totally fine. You just have to be aware of the problems that do give you a negative under the radical and be sure that you know how to deal with those complex roots. All right, so looking at number 3, we have 2b squared plus 3b plus 2 equals 0. So like I said, I'm going to go ahead and use the quadratic formula for this one. To me, it doesn't look like factoring is going to be super effective, and we do have that bx term, so I'm not going to use, I'm not going to try to solve by taking the square root. It simply won't work. If you wanted, you could complete the square, but this middle term is an odd number, so that's not going to be pretty. So I'm going to use the quadratic formula. So just for good measure, our A term is 2, B is 3, and C is 2. I'm going to plug this into the quadratic formula. So you have negative b, -3, plus or minus the square root of b squared, so 9, minus 4 times our a value, which is 2, times c, which is also 2, all over 2 times that a value, which is also 2. All right, I'm going to take this one step at a time. I'm going to solve everything underneath the radical first. Remember, bonus points. Underneath that radical, the term, hope you guys are thinking of it in your head, that's called the discriminant. So the 9 minus 4 times 2 times 2, that is your discriminant, that value. Remember, we took that piece out when we were solving the discriminant. So I'm just going to simplify that. 9 minus 4 times 2 times 2. So negative 4 times 2 is 8. Negative 8 times 2 is negative 16. So we have 9 minus 16. So this whole thing is going to be negative 3 plus or minus the square root. And when we solve that, we got negative 7 because 9 minus 16 is negative 7 all over 4. This is all over 4. Now, when we were in the classroom, I saw so many of you did not write it all over 4. Instead, your line would be short and you would only do part of it. Remember, it is the whole entire thing up above, all divided by 4. So, of course, we don't like having a negative under the radical, so we cannot leave our answer like this. We want to be sure to take out that negative and write it in the proper form. So we have negative 3 plus or minus. I'm taking out that negative, so I'm going to write I on the outside, because remember, I is equal to the square root of negative 1. So we have negative 1 times 7 over here. So I'm taking out that negative 1 and writing I, but we still have the square root of 7 left. And that is all over 4. I just want to show you a couple of different ways that your answer can look. Of course, that highlighted one on top, negative 3 plus or minus I rad 7 over 4, that is perfect. That's how I like to write it. It's the simplest, easiest way to write. Doesn't require a lot of extra writing. In the purple one, the second one down, this is the way you'll see it in the answer key. So they just simply separated it. You have negative 3 plus I rad 7 over 4 and negative 3 minus I rad 7 over 4. Again, they just rewrote it twice. It doesn't make anything different. And then this last one in green. I wanted to show you guys what it looks like to write it as a complex number with the real part and the imaginary part. So I just broke up the pieces and wrote the numerator over the denominator. So negative 3 over 4 plus rad 7 over 4 I, because that's your imaginary part. And then the same thing with the subtraction sign. So if you were needing to write it with the real part and the imaginary, that's how you'd manipulate it to look like a complex number. But the highlighted version is totally fine with us. Just wanted to show you guys what that looks like. We're going to go over one last example to show you guys one extra piece. Here's our quadratic. I already looked at the a, b, and c variables. Now we're going to set up that quadratic formula. So x equals negative b to 4 plus or minus the square root of b squared is 16 minus 4 times our a value times c all over 2 times our a value of 3. When we simplify this, we are left with 4 plus or minus the square root of negative 44. So you guys can multiply that out, no big deal, and get negative 44 all over 6. So a couple different things that we need to look at here. One is we have a negative under the radical. And two, we can also simplify this number. It's too big. We can find a perfect square root to take out of that, a perfect square to take out of there. So I'm going to pay close attention to this part of this just for a second. So over here, the square root of negative 44. One thing is we have a negative number, so we want to take that out. When we take out that negative, we can rewrite that as I square root of 44. Second thing is this number can be simplified. We can take out that perfect square. The largest perfect square we can take out of this is a 4. 4 times 11 with that I there. The square root of 4 is 2. The 2i rad 11 is what that number simplifies to. So that's going to go right in there. So I wrote the simplified version in green right here, and we'll see one more thing that comes into play with this one. We have a 4, 2, and a 6. We always want to be sure that our answers are in simplest form, and in this case we can use that heart like we've done before. Do a little heart action like we have done with our quadratics, and we can simplify this. So in this case we can take out a 2 from each of these, and we will be left with 2 plus or minus I rad 11 all over 3. There we go. So this is going to be our complex root, there we go, for our quadratic. That's it on complex roots. Remember, on your assignment, you're going to be solving the quadratics using whatever method you like, There will be some with real solutions, and then always look out for the ones that will have imaginary solutions when there is a negative under the radical.